Hi, writing the equation of a line passing through the 2 points. I will take two different approaches to this today. One will be first graphically, the second will be algebraically. So starting with our graph, because we have our coordinate planar axes set up, let's just go right ahead and graph these 2 points, plot them. So -2, -3, and then we have positive 1, 2, 3, positive 7. 1, 2, 3, 4, 5, 6, 7. There we go. Those are our 2 points. From these 2 points, you can create a right triangle, sometimes referred to as a slope triangle. That gives us our rise over our run, and that is a component of slope, a very important component of writing the equation of a line. The form that we are looking for here, y equals mx plus b, that is slope, intercept. Later I'll give you a video and I'll let you check out point slope form of a line. But right here, we can count our rise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have a rise of 10 and a run of 1, 2, 3, 4, 5. Rise of 10, run of 5, and I always think about this in terms of positives and negatives. The right hand is the positive hand, so if the right hand were up, your line is going in that direction. If the left hand was up, it would be going in that direction. This here, hopefully you're understanding, has a positive slope. So slope is rise over run. So I have a rise of 10 and a run of 5. This is a positive slope line. Don't forget your positive, negative. We can reduce that to 2. So we go up 2 and over 1. That is our slope. So if you were to apply that slope, starting here, we would go up 2 and over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. And there you go. That really gives your line a little bit of shape there. Coming through, it would continue on in both directions. But as you can see, my little ID card has kind of run out of room, but that is a nice idea of what your line will look like. Now the second important component here is the y-intercept. This graph crosses at a nice even point. That is 0, 1. 0, 1 is your y-intercept, which is the b value. So having those two things, if it falls on a nice lattice point, an intersection point here like it did, you can go right ahead and write the equation of the line. Y equals, let's substitute in my 2 for my m, my slope, so 2x, and then you have a positive 1 plus 1. That right there is the equation of the line. If it crosses on a nice lattice point, you're able to figure this out graphically. If it doesn't in some cases, and even if it does, you should have the algebra to fall back on. So let's take a look at that now algebraically. My 2 points, starting fresh, -2, -3, and 3, 7. So the two components that we talked about that we need for our equation of a line, we need slope, m, and we need a y-intercept, b. So first of all, let's find slope. We talked about rise over run. That's graphically, and that's really what it represents, but you also have an algebraic approach to this. Slope equals y2 minus y1 over x2 minus x1. Now, the ones need to stay with the ones, and the twos need to stay with the twos. So if I were to make this x1, then this would need to be y1. If this is x2, this would need to be y2, and vice versa. It doesn't matter how you order these two things. As long as you keep the ones with the ones and the twos with the twos, everything will go right ahead and work out just fine for you. So, doing some substitution, please try to use your parentheses when you substitute. y2 minus y1 over x2 minus x1. Now we're just really doing a substitution in here. So first, I need y2, which is 7, minus y1, which is -3, over x2, which is 3, minus x1, which is -2. Now I see this double negative, and immediately I am thinking, oh, double negative becomes a positive. So now when we clean this up, we get 10 over 5, which reduces to 2. So we have a slope of 2 just like we found graphically earlier in the previous example. So now you are going to pick one of these points. Either one, it doesn't matter. The 1s or the 2s, it is completely irrelevant, and if you do everything correctly, you will end up with the proper b value, the proper y-intercept. I see this equation, and I recognize that there are 4 variables. 1, 2, 3, 4. Y, m, x, and b. We have an m. You also have an x and a y. Knowing 3 out of the 4 variables allows you to solve for the 4th. So we are going to substitute y equals m, x, plus b. Y equals m, x, plus b. Now let's just say we pick our first point. Like I said, it doesn't matter, so let's take the point of -2, -3, and we have an m value of 2. We can sub right on in here. So my y value is -3, my m value is 2, and my x value will be -2. So let's clean this up and see what happens. -3 equals -4 plus b. Add 4. 1 equals b. We have a y-intercept of 1, just like we found graphically. So now we can rewrite our equation with our b value and our m value. Equation of the line, y equals 2x plus 1. Exact same thing that we found when we did this graphically. So let's take a look at these two things together. If we can. Kind of running out of room there, but there's the previous work from our graphing method. Here's the work from the algebraic approach. I hope that helps. See you around.